Alright, what I want to have a look at is the concept of the zero index. And what I'm talking about here is I'm talking about taking any number and raising to the power and wondering what sort of answer I could get. Now I can get a zero index by starting off with a division, because we learnt that when you divide you subtract indices. So 2 cubed divided by 2 cubed would be equal to 2 to the 3 minus 3, which I can see is equal to 2 to the 0. So that's one way to generate a zero index. Now from that though, I know 2 cubed is 8, so this is actually 8 divided by 8. And 8 divided by 8 you know is 1. So I can see that 2 to the 0 is equal to 1, which gives me a clue that maybe when I raise the power of 0 I get 1. I'll look at it another way, and I'll look at it by generating a pattern. So I'll start off by keeping the powers of 2 here. I'll say, well, I know that 2 to the 4 is equal to 16. 2 cubed is equal to 8, and to go from here to here, really I'm dividing by 2. So 2 squared is equal to 4, another division by 2. 2 to the 1 is simply 2, another division by 2, and finally then 2 to the 0 divided by 2 is equal to 1. And realistically I could do this with any number, not just 2, I could do it with 3, 4, 5, 6, 7. And so for the zero index, the general rule is if I take any number and I raise it to the power of 0, I get 1. And that's my rule. Any number raised to the power of 0 is 1. So as a quick example over here, find 2m to the power of 0. That would be simply 2 times 1, because m is to the raised to the power of 0, which we know is 2. However, if I said find 2m all to the power of 0, then 2m all to the power of 0 is going to be 1, because the whole thing's raised to the power of 0. So that's the zero index and how it can be used. Continuing the pattern on, then, we can have a look at the idea of a negative index. So what happens when I raise a number to negative 1 or raise it to negative 2 or something like that? And so I ended up with my pattern. I said 2 to the 1 was 2, 2 to the 0 was 1, and I was dividing by 2. So I guess if I want to go to 2 to the negative 1, then I want to keep this division by 2 happening. And I know 1 divided by 2 I can write as a half. And if I want to go 2 to the negative 2, then I want to keep dividing by 2, and keeping in fraction form, a half divided by 2 is a quarter. So if I have a little bit of an explore of what I've got here, I've got 2 to the negative 1 is really 1 over 2, or 1 over 2 to the 1. 2 to the negative 2 was a quarter, which is 1 over 2 squared. I can conclude that 2 to the negative 3 dividing by 2 as a fraction is 1/8, which is going to be 1 over 2 cubed. So it leads me to this point where raising to a negative power is actually moving the index underneath. It's moving it to the denominator. So the idea here, one of the ideas used to reinforce this concept, is the idea of having 2 stories, and this being like a little elevator. So I've got 3 to the negative 2 sitting in a 2-story building. At the moment it's on the top floor. And then what I want to do is press the button, and when I press the button it changes floors. It drops down to the 2nd floor, and I'm left with the 1 on the top floor. So 2-story elevator, press the button, the negative sign, it drops down. Notice the button's no longer there, 1 over 3 squared. So in general, if I take any number and raise it to a negative power, I get 1 over that number raised to the power. That's my rule for negative indices. Let's just have a quick look at an example of those negative indices in action. So let's just take 4 to the negative 3. That would simply be press the button, change floors, 1 over 4 cubed. And then 1 over 4 cubed I could write as 1 over 64. Working backwards the other way, if I said express with a negative indice, so if I had 1 over 2 to the 6, then that would be 2 to the negative 6 working backwards the other way. If I had 3 over 5 cubed, then the 5 is what's on the bottom, so I've got 3 lots of 5 to the negative 3. It's only the 5 that's raised to the negative 3 there. And the 3 was already on the numerator, already on the top floor, nothing's going to change. So I'm keeping it like that. Here's a slightly harder one. If I had 1 over a to the negative 5, then if I want to say write without negative indices, then what I'd be doing is thinking again this two-story building, and I'd be pressing the button, the negative sign, and I'd be changing floors. So press the button, that brings up to the top. It becomes a to the 5. 1 over a to the negative 5 is a to the 5. I can quickly show you that as a fraction for those of you who want that explanation. So 1 over a to the negative 5 is 1 over a to the negative 5 is 1 over a to the 5. So that's that part there. And then mathematically, when we divide fractions, we actually invert and multiply. So we invert the denominator, the second fraction, and multiply. You can see that I've just simply got 1a to the 5 over 1, which is just a to the 5. Just a few more examples. So if you're asked to simplify something like, in brackets, 3m squared all to the negative 2, then what that would mean is I would want to change floors. So I'd press the button here, I would change floors, I'd make it 1 over 3m squared, all to the 2. And then I can just keep it as 1 over the fraction and go 3 squared is 9, m squared, I multiply those together to get m to the 4. Okay, alternatively, if I have a fraction and I want to raise it, so if it was something like expressed without, something along these lines, and I had 2/3 all to the negative 3, then when I press the button I change floors. The whole thing changing floors means they're both raised to the negative. I have to change floors like that. I take the reciprocal, I flip it upside down, and then the button's gone, so I just have 3 over 2 to the power of 3. And then 3 cubed is 27, 2 cubed is 8, so I get 27 over 8.